Friday, Baylor College of Medicine and friends of Baylor College of Medicine. Today, it's what an exciting week we've had, and today we're going to be talking about variants of concern. Now, as you know, my sister lives in New York, and so we are not talking about people from the East Village, Janet. Those are other variants of concern. And before I start, because my sister's beginning to think I'm a variant, I wanted to point out that I have a pet peeve. I really can't stand people, mostly horse people, that have horse everything, horse mugs, horse pens. Excuse me. Horse ties. Those people are variants, and I'm not talking about them because I don't have any of those problems. I'm not like that. But anyway, let's start talking about how things are going in the U.S. Pretty good in a pretty bad way. We keep setting records. We're now over 100 million cases and over 400,000 deaths. I mean, I think we're going to end up closer to 500,000. It's been a heavy slog, and of course, the United States is leading the world. We lead with this giant spike here, but things are beginning to taper off in the U.S. I'm excited to see that finally we're beginning to get a plateau. And Texas is also beginning to get a plateau. And as I've mentioned before, Houston is doing better than many of the other cities. And this is an average daily case per 100,000 people in the state of Texas. And one of the great things that you can see, Houston is doing better than most of the other big cities. So I'm really proud of our community. I think everyone has been taking it very seriously. And the United States, it's again interesting to see where the new cases are emerging. It's not in ones you'd normally expect, or you'd expect from previous rounds of infection. Rhode Island leads infections per capita on a 7-day average. Arizona, South Carolina, Georgia, New York, California, North Carolina, of course, and then so Texas is behind in that. We're doing better. There's one particular hotspot still out in Abilene. Don't know what's going on out there, but there are emerging hotspots. So the main thing is with the start of the vaccines and the rollout of the vaccines and people apparently doing better at public health measures. We're beginning to see the flattening of the curve nationally, and I think what we'll begin to see is it begin to fall. The big unknown in this is the role that variants of concern will play, because the variants that we've been talking about have some issues in terms of increasing infection rates and maybe increasing mortality, and a lot of debate about whether or not the vaccines will still be effective. The key is in the spike protein. This is the structure of the spike protein, and you can see the receptor binding domain is the area that binds to the ACE2 receptor. And if you recall, we sort of talked about the hand-in-hand approach. The spike protein reaches out, and the ACE2 receptor grabs it, and then it pulls in. There's a domain of the spike protein that leads to membrane fusion and the virus entering. So those are the key things, and mutations in that receptor binding domain have the potential for changing the infectivity of the virus. So if you'll recall, the very, very first virus that started in Wuhan was quickly replaced by the first strain, which was an aspartate to glycine mutation. It's called D614G. It sounds complicated, but it's actually not. There are about 1,100 or 1,160 amino acids in the spike proteins. That's the various building blocks that make the protein. And the 614 position in the 1160 had a single amino acid replacement from D to G. That was more infectious and became the dominant strain throughout the world. The first real one of concern we've talked about for the last couple weeks has been the one in South London, originally identified in Kent. And that one is called the B.1.1.7 strain. And that has in the 501 position another mutation, N to Y, which is cysteine to leucine. And the reason that's important, it's in the receptor binding domain. That particular mutation leads to about a 70% increase in the binding affinity, in other words, the tightness of the binding of the spike to the receptor. And that led to increased infectivity and a huge spike in cases in southern England. That was not just the only mutation. There were 8 additional mutations that were formed in the spike protein. And there was some concern, while it was pretty clear that it increased infectivity, there was some concern it might actually increase the morbidity. And so there has been a few studies, and we have, it's not all that clear from the data, but it looks like there's a slight increase in the mortality in that particular mutation, although it's not really all that pronounced. The good news is that several examples, the Moderna vaccine and the Pfizer vaccine, have been shown to be effective against that particular mutation. So while we're concerned about it, and it is present in the United States, and the real issue for us is, will it lead to increased infection number in the U.S., the vaccines should take care of that particular variant. So that's not a big concern. The second new variant was identified in South Africa. That has the same 501 mutation as was seen in the United Kingdom, but it has additional mutations. And that's the real concern. And what happened with that particular strain is that if you look at patients who've been infected with SARS-CoV-2 and take their plasma and look at neutralizing antibodies to that particular viral strain, it looks like there's about a 10-fold reduction in the ability of the antibodies to bind and neutralize that. If you do another experiment where you take the people who've been vaccinated, not just the people who've been infected, but vaccinated, there's about a 6-fold decrease in the neutralizing activity. That does not mean it won't work at all. With a 95% effective vaccine, it may reduce the effectiveness a little bit, but it does not mean that it won't work. And so that's something we still have to look at, but it's obviously an area of concern. There's a third variant now, P1, that is from Brazil. And that one has 17 amino acid changes and 3 deletion mutations. And in particular, there are 2 additional mutations in the spike protein. And this was identified in 40% of sequences that came from an Amazonian city called Manaus. The reason this was a concern is 70% of that population had been infected already, and all of a sudden there's this huge spike. And the concern was this particular variant is even more infectious and potentially might avoid the effects of the vaccine. So we don't know that yet. That particular variant has just arrived, we think, in one cases in Minnesota, and that's it. So, what do we do with all this? Well, there's a couple of strategies. The first potential strategy is an additional booster. Maybe you can boost titers, and so Moderna has started a trial to see whether an additional booster to the second booster might actually provide enough increase in antibodies that would be effective. The other thing about, we've talked about how easy it is with this mRNA platform to change. The way it works is real simple. There's a sequence of nucleotides that reads out, is translated into these amino acid building blocks, and it's just like a typewriter. You can just type out a new sequence and create a whole new vaccine. And so it is possible that if these variants really do evade the neutralization from the current vaccines, we can roll out annually new vaccines that really address new variants. That's what we do with flu every year. Now, the good news is it is unlikely that it will be annual, and if we get the whole viral burden down in the world, so fewer and fewer of these mutations are evolving, it may be that we need to do that every couple of years, every 3 years, or maybe it goes away entirely. But right now, those are the ways that are being we're considering potential approaches to these new variants and new variant strains. It also emphasizes the point that every time a viral copy is made, there's a potential for an error. I mean, it really is like a typist typing sequence. And when there are trillions and trillions of viruses being replicated, there's all these mutations. The vast majority of mutations don't even change the amino acid sequence of the protein, don't do anything. The other majority of them make the virus less fit. But every now and then you get one that makes the virus more fit, like these particular 3 mutations. and they begin to emerge. So the fewer times the virus replicates, the less likely you are to have these mutations. So one of the really important strategies is vaccinate everybody and have everybody stop transmitting the virus. That will reduce the global viral burden, and we'll have just a whole lot less of virus. Now, the monoclonal antibodies are a different thing because the monoclonal antibodies are directed to the very specific component of that spike protein. And so it may be that these mutants will make it more difficult for the spike protein, to neutralize the spike protein. So while the vaccines still look promising and still should be okay for the vast majority of the virus sequences we have, the monoclonal antibodies may not, and so there's studies ongoing to look at that. I wanted to spend a little time talking about some really cool new developments about potential therapeutics. There were 3 really great papers that came out in Science just this past month, and they were a little shout out to one of my former faculty members, Adolfo Garcia Sastre, who's been part of this consortium. Adolfo is a flu virologist that was in microbiology and medicine at Sinai, and that consortium has been looking at potential new therapeutics. So we talk about the genome all the time, or the proteome. There's something new that's called the interactome, and this is something where these scientists have taken each of the 3 recent coronaviruses, SARS-1, MERS, and SARS-CoV-2, and looked at all the different proteins in a cell that might interact with the virus machinery. And in each case, there were 300 different proteins in a cell that might interact with the virus itself in the viral replication cycle. And so they looked at the common ones for all 3. And then they started looking at all the potential drugs that were already on the market that might impact one of those proteins and might interact those pathways. And they found, amazingly enough, that there were a couple of drugs already approved that might have an impact on the ability of this virus to replicate. And there's one really important pathway for this virus. So when the virus gets in, I showed you a previous video of how the mRNA for the vaccine comes in and is transcribed. Well, the virus does the same thing. The RNA gets in, it's translated into proteins so that the virus can replicate. And one of the important methods for it to do it is to take the host machinery, and one of the really essential components is the ability to elongate the strand. And there's this elongation factor, very important for RNA to be translated. Same for the virus. And there is a drug called plitidepsin that has been used for multiple myeloma, and that particular drug impairs the ability of this elongation process. And turns out it actually inhibits viral replication 30-fold more than remdesivir. So just by doing this relational strategy and looking at the mechanisms of cells replicating themselves and the ability of the virus to take over that machinery, these investigators have come up with several drugs that might be useful for all coronaviruses, or at least these 3 types of coronaviruses. So very, very exciting work that I think has tremendous implication for future drug treatments, antiviral treatments, in addition to our vaccine strategies. So lots of positives, very great news on the vaccine front. The administration is talking about enhancing the rollout. There have been another couple 100 million doses that have been bought by or purchased by the United States. So we are excited about seeing whether or not we can get this pandemic under control as soon as possible. I just want to point out, Jim McDevitt had a really nice opinion paper, a little note that I think is worth reading about, having a strategy to try and get this under control by July 1st. I think it's a great idea, July 4th actually. And I think that, if we all really work together and focus on public health measures and getting vaccinated as quickly as possible, we have a really good chance of getting the epidemic in the United States, the global pandemic, under control, hopefully by the fall. So a lot of good news, a lot of positive things on the horizon. A lot of great work going on across the country and around the world in science to really get this under control. So with that, I hope you have a wonderful weekend, and I can't wait to see you next week.